Hi there, Keith Wiggins back with PAG Waste Management. I wanted to go over specifically figure 4.4 and get it explained a little bit more clearly. So, as you can see, for your figure 4.4, uh, this chart it basically depicts the theoretical performance of a biomass gasifier under various conditions. It's not based on real world data, but rather model predictions based on chemical equilibrium of the gasification reactions. The x-axis of these charts is the equivalence ratio. The equivalence ratio compares the amount of oxygen supplied to the amount required for the complete combustion of the fuel. That's what it stands for. So part A of the diagram over here shows the adiabatic reaction temperatures for biomass gasification. Adiabatic means that there is no heat transfer in or out of the system. The reaction temperature increases as the equivalence ratio increases. This is because more oxygen supplied leads to a more exothermic reaction, or one that releases heat. Part B of the diagram shows the equilibrium gas composition for the reaction with air. So the y-axis shows the mole fraction of the various gases in the product gas. As the equivalence ratio increases, the concentration of carbon monoxide in the product gas decreases, and the concentration of CO2 increases, right? So carbon monoxide, and you can see CO2. This is because with more oxygen, there's more complete combustion of the biomass to carbon dioxide and water vapor. Part C of the diagram shows the distribution of energy in the products. As the equivalence ratio increases, energy content in the solid product, char, decreases, and the energy content in the gas product increases. This is again because more complete combustion with more oxygen leads to less char and more gas production. Part D of the diagram shows the energy density of the product gas. The energy density is defined as the heating value per unit volume of the gas. The energy density increases slightly with the equivalence ratio. However, this chart suggests that maximizing the energy density output from the gasifier may not be the best strategy, because maximizing energy output comes at the expense of reducing char production. Char can be a valuable byproduct that can be used for other purposes, right? So it's a trade-off, and you just need to, based on what you're using this gasification for, or your downdraft gasifier for, you want to make the right choice regarding your equivalence ratio. Anyway, thank you very much. Just wanted to explain that a little bit more, and we'll chat with you later.